joining us. This is Paul Wilson.
And Chris Emke.
You're listening to the Diesel Performance Podcast. Chris, this week at Calibrated Power, we've been talking a lot about ag tuning.
Yeah, well, internally, and I think that's because a lot of interest, this time of the year comes swarming in, right? And it comes in full swing. So over at Calibrated Power, we have a big one of the big focuses, right, in one of our departments is agricultural tuning. So we support pretty much all the big tractors, Case IH, Versatile, New Holland, Cat, Challenger, John Deere, of course. Yeah. It's really cool. We've been doing this publicly for about 6-7 years, and Nick was doing this with some local farmers a couple years prior to that. And it's crazy to think that these manufacturers of tractors, combines, sprayers, all these different, tools.
Yeah.
You can buy a unit, if you will, and, there's different series, with these or different models within the series. And a lot of them at the same time will have like the same ECM, fuel system, air charge system, turbocharger, drive line, what have you. And it's limited by a calibration.
Do you know what jumps off the page to me is I think one of the most common tractor engines we tune is a John Deere 9-liter.
Yeah, and that 9 liters widely used.
Widely used. Yep. It's in their 8 series. It's in their larger series. Yep. It's in their smaller series. We find it all over the board. Yep. And we found as you dig into it, a lot of these models, and even as they cross series, a lot of these have
share a lot of the same components.
We have learned throughout the years that, hey, man, there are some of these that once you jump a series or you go past a certain number, hey, there's a weak link somewhere else, right? So it might not be the turbocharger or the cooling system. It might be something in the chassis. What's great about working with us after we've been doing this for so many years and tuned so many tractors is we know that we're going to get you something that's reliable and safe.
Well, I just had a guy inquire about a tractor like last night, and this morning we've been emailing back and forth, and it's an 8R series, and understanding the break-off on the 8Rs for what kind of power can be had when you're talking about like a smaller 82, like 45R.
Yeah.
Right. So, we have a lot of experience. I never chose to have this experience, right? It's just that you learn it as you go type thing. But I'll get guys all the time. They'll call in like, hey, I have blah, blah, blah tractor. I need 100 horse. And you kind of back into, well, horsepower is always the easiest way to identify what we're doing in tuning.
Right.
But the reality is the torque, the torque output and the torque curve, right, that the tractor is operating under, those are where the gains are going to be had.
That's right.
So always backing into the question, how are you using the tractor? What's your ground speed? What RPM are you operating at? And then backing into being a little bit more educated on what kind of power they need.
Right.
And what's nice is we can offer a support, offer an uprate, and if we have to revisit the tune, we can do so then as well. And you save your stock file. So, if you have any questions, guys, on that stuff, we offer that support. We're also looking for dealer recruitments on that stuff. There's a lot of cool creative packages that we offer on stuff like that. So, if you have any questions, give a call over to the shop.
Absolutely. And that number is 815-568-7920. Hey, guys, another shop you should give a call over to is WC Fab. Chris, I was just taking a look at their upper coolant pipe for the 2020 L5P Duramax. Yeah. Now, this replaces the ugly OEM rubber upper radiator hose with a fabricated aluminum hard pipe that's powder coated in your color choice. So we've always talked about WC Fab's amazing powder coating, WC Fab's fit and finish, WC Fab's superior quality, and I know that's what guys are looking for. So this is more of a dress-up piece. I don't think we're going to see, real changes in performance, but it is going to clean up your engine bay appearance. It does also include high-quality silicone boots and stainless T-bolt clamps, much better than what you have from the factory there. And it will fit on stock trucks with no other modifications necessary. And, of course, here's one of my favorites because I'm a dum-dum when it comes to tools. It does install easily with basic hand tools. This is a job even I can do.
I mean, this is like a focal point. Pop the hood. It's right there.
Yeah.
It definitely dresses it up. It definitely, sends a message, and it dresses up really nicely.
That's right.
Absolutely.
If you've wasted your money on rims and tires, you'll also like this.
Another shop that we rely on heavly is Exergy Performance.
Sure.
Especially with their upgraded injectors. And I kind of wanted to point out, in the LML world, right, these trucks are starting to get a little older, okay? Guys are starting, if they haven't had a CP4 failure and they're having injector issues and they want to upgrade, most commonly, a nice, small, simple upgrade, because not everyone's looking for a 1,000-horse truck, is their 30% over injectors.
That's right. And these are so easy to overlook. And I think it's because so often when I'm talking to customers, we end up having the discussion about Sportsmans, which are like they're basically stock replacements. Yep. They're 5 or 10% above stock. And then I feel like the other end of the spectrum is we talk about the hundreds. Yep. And we talk about, well, what happens when you get past hundreds and you're now getting out of extrude honing and other things like that. The 30%, though, these really hone in for your daily drivers that want that, like you said, streetable upgrade.
Yeah, I think that this is, hey, I got a Stealth 67 on the truck, a Stealth 64 even maybe. I have a twin turbos on the truck, whatever the case may be. I'm looking for that little extra edge, and a stock injector just isn't going to do it.
That's right.
Okay. So whether you have to replace your injector or you just simply want to send them out, have them tested, baselined, then you know what? Let's just hone them out 30 over for efficiency purposes.
That's right. One of the cool things I like about that process, when you're sending it in or when they're doing their own injectors, right? If you're going for remans or for news, they all get that same treatment. So the injectors come into Exergy. These guys came out of Bosch, like actually the engineers over at Exergy actually came out of Bosch. So they really know what they're doing. They have top-of-the-line equipment. And just like you said, so they baseline them, they test them, determine if the injectors are within spec. Then once they are, they modify them. If they're not, you get notified. You get detailed pictures. You get a detailed analysis. You know exactly what you're dealing with. There's no guessing game. There's no, they said 2 of them aren't good, but I don't know why. You don't play that game with Exergy. You know exactly what's going on, and you can see it. So then they actually pull them into a tolerance that's tighter than OEM.
Yep.
So OEM has a 5%
plus or minus 4.
Yeah.
Yep.
Well, balance rates are plus or minus 4. I believe their tolerance rate was.
Oh, the balance rate itself.
That's right. Yeah.
The flow rate.
So when they're actually doing their flow rate, they all have to be within 5% of each other, I believe, is factory spec. Exergy pulls that down to 3.
Oh.
So they're really, really tight tolerance, extremely precision, and that's what we're looking for when we're talking about fuel systems, especially with LML injectors, because they're that piezo-based injection system, not a solenoid-based.
Well, all common rail injectors, I think the bigger picture here is whether you're buying a fresh set, I'll call it fresh because they offer reman and new.
Sure.
You buy a fresh set or you have your set sent off. They don't mass produce injectors. So they take a set of 8, build a set of 8, flow a set of 8, balance a set of 8, test a set of 8, and those are the 8 or the 6 injectors that you get sent.
I love that.
Okay. And they offer flow rate sheets. They offer everything in black and white for you to reference. These are my injectors. This is what I'm getting. So it gives you a little bit more of that I'm part of the process feeling when making upgrades to your truck, which, for me, it's big money. Injectors are expensive.
Yeah.
There's no secret about that. And these are the values that you get by spending the upper part of the spectrum of what injectors cost because of the value you're getting in return.
That's right.
So
I love that. Chris, today we're going to dive into one of our more researched episodes. So we've done some of these kind of deeper dive research episodes. We really enjoy doing them. I think the listeners enjoy hearing them. Guys, we'd love to hear your feedback on that. Please jump over to the Fans of Diesel Performance Podcast Facebook group. Got a lot of cool stuff going on there, a lot of cool posts. Hey, did you see Ian Weiss did 10s on a stock injector, stock block, stock turbo LLY?
No.
All spray.
He's
still together.
Jesus.
He actually has a few other mods. Ian Weiss was recently on. Guys, go back, check out the episode. I question myself on saying stock turbo, but I know for sure stock injector, stock block, LLY in the 10s. It's a 1096. He just posted the video on our Fans of Diesel Performance Podcast Facebook group. Great job, Ian. If you would like to be a member on the show, jump onto that group, and there's a place where you can sign up and get on the schedule.
I'd like to know how much spray he was spraying through that thing.
I think we're going to have Ian back. Today, though, we are diving into the history of Duramax turbocharging. Duramax has been around since 2001. They're still running today. It's always been a 6.6 liter. It's the only manufacturer that's held out the displacement throughout their entire life since 01. So I think it's going to be a cool topic. I used a lot of resources for this. The ones that I wrote down were DuramaxHub.com, one of my favorite places to go, iHigh-turbo.com, Diesel International, Driving Line, specifically the Duramax history, all of the lessons that were by Mike McLaughlin. There's like 1 through 7, I think it is. They were all awesome. Great job, Mike. Also used Diesel Power Magazine. I used an article that was the 01 to 04 Chevy LB7 Duramax. Used Diesel Resource. I used GarrettMotion.com. I went around and tried to find as many places as we could to pull this info together. Now, Chris, you and I have quite a bit of, I call it tribal knowledge around these turbos, right? We deal with them every day, and we've talked about them for years. I thought I'd let you kick it off with the LB7.
Yeah. So what's the LB7 is such an iconic platform, I feel, in diesel. Okay. Yeah. It was the first on the market in this light duty pickup, medium duty pickup trucks, whatever you want to call them, common rail injection, right?
That's the big one.
It's the big one, and they packed a big turbocharger, all things considered, to produce some pretty respectable power.
Especially compared to its predecessor, where the 6.5 is what came before the LB7s. Yep. And I know on my 6.5 and probably all of them, there's a big sticker on the intake that says, "Do not spray ether."
Yep.
Because it will explode this turbo.
And I think a couple of the things that made this engine so cutting edge, the common rail injector and common rail injection system, that's the big thing that pops up. But it was an iron block with aluminum cylinder heads. It had the Allison trans, which was a big deal, and to this day is still deemed a big deal. Yes. You always hear the guys, "Oh, if I get a Cummins with an Allison behind her,
not a Ford chassis,
not always Ford." Yeah, Jesus. But the Duramax came out in 01 with, swinging hands, like it had something to prove. It had forged steel rods with aluminum pistons, 300 horsepower, 520 foot-pounds of torque. Now, let's put this in perspective, okay? If you were to have purchased a 01 Cummins of this year, it was at best a whopping 235 horse.
Sorry, 7.3 was even lower, wasn't it?
7.3s were under 200 horsepower.
Yeah.
I think like 190, 200 and something, very, very low. So legitimately 300 horse, 500 foot-pounds of torque out of the gate, again, swinging, right?
You know how the 2019 Cummins came out with the high output and the 1,000 foot-pounds of torque, and it was like, it's a huge deal.
Yeah.
One, pretty short time span. We're talking about just 19 years. We're almost doubled our torque output in highest torque of an available diesel. But just think about like the Duramax and the Ford in that same year of 2019s are in the like 800 to 900 range of foot-pounds of torque. So they, like Cummins, they have the most, but not by a huge leap.
Yeah.
It does not take much to catch them. In the Duramax, getting 500 foot-pounds out of a 7.3, it's possible. Yeah. But you're putting some money into it for real. Yeah. And at Cummins, we know we can do it. But again, not the design from the factory.
No, I mean, especially when you're talking these years, I mean, it's very easy to take this 300 horse, 500 foot-pound truck to 400 horse, 700 foot-pounds really easily. Like, snap your finger, tune, you're there. It's crazy to see the technology. But back into this, it came with an iHigh RH G6 waist-gated turbocharger. Now, what's funny about this is not funny, but this is the only turbo in the Duramax lineup that's non-variable vane.
That's right, yeah.
Only the only iHigh charger.
That's right, the only iHigh. They got away from the iHighs pretty quickly. Now, iHigh Turbo America, or iHigh in general, I didn't realize they're still a big deal today. In my head,
it's just not in our industry.
Right. I was like, iHighs, those were back in 01 to 04, no big deal. Well, iHigh America is the U.S. subsidiary of iHigh Corporation. They're North and South America. They do turbochargers. They do superchargers. They consider themselves a Tier 1 supplier to most manufacturers of diesel, gasoline, fuel cell, natural gas vehicles. They're all over agricultural, industrial, marine, commercial, military, and they're still in some passenger vehicles.
Wow.
So I didn't realize the scope of what iHigh still covers today in 2020. But as you dig through the stats on that original LB7 charger, Chris, I think it's also a bit of an eye-opener on how cool this was.
Mm-hmm. Yeah, I mean, 60, call it a 60.5 millimeter inducer compressor wheel. What's odd here is it's a 58 millimeter exducer, so a fairly small turbine, and we'll dive in more with the other turbos on why that, what's ironic about that. Peak boost was around 20 to 22, 24 pounds, and tuned up, low 30s is what you would get out of them. You do your boost increase valve mod and tune it up, right? And it was waist gated and fixed vane, which when you do a variable vane turbo, you don't do wastegates, because the vanes control that. So this, like I said, is the only one that is wastegated and fixed vaned. And common failures, and we see this because I have to take a step back sometimes and realize that this is a 20-year-old platform.
Right.
20 years old. But, when you're pushing those turbos into the 30-plus pound range, you are overspeeding them. They are out of their efficiency range.
Well, there's also guys who it's funny you mentioned the boost increase valve, but if you go hit the old school forums.
Oh, you just block the gate.
How many guys just block the gate?
Yeah, I did that.
Right,
yeah.
Of course.
So overspeeding, right?
Yep.
Very, very common. Contamination. These engines are getting older. You don't know if you're getting debris, not changing out your air filters, and just age. Unfortunately, it's just a simple age thing.
You had an LB7. Did you do the LB7 airbox mod? Where you cut out the bottom of the factory airbox?
Yes. Yes,
of course. Of course.
Yeah, my LB7, I had our Stealth 64 on the truck with the box cut out.
Yeah.
And it
Why
worked.
Wouldn't you?
Yeah.
Why wouldn't
you?
Well,
free.
One of the reasons you wouldn't is because it increases your potential for contamination.
That's all hearsay. That's all hearsay. No, you're right.
I hate you. Because you're just looking for more problems, right? So as guys were getting into these, that's really where we see them fail. And Chris, I've seen some really cool failures back in the Stealth Turbo Bay.
Some really cool failures or some really sad failures that cost customers.
Well, it depends on who's paying for it. Since I wasn't paying for any of them, they're
cool. Okay.
But I have seen where guys have, I don't know what melted, but we found actual molten
yes.
metal on the back of a turbine. And I'm just going,
maybe that was Ian's turbo.
Was that the pistons?
Maybe that was Ian's turbo. Oh, man.
But yeah, we have seen some nasty stuff come up. What we don't see a lot of is soot contamination. So we don't see a lot of LB7 turbochargers fail because they bring in a lot of soot. Now, as we get into the variable vanes...
Well, there's less moving parts.
There you go.
Right.
There you go.
It's a very simplistic setup.
So with a peak of about 520 rear-wheel horsepower on these trucks, you're still getting a lot out of it. And as we move into some of the newer models, as we go forward, you'll kind of see what you're giving up and what you're gaining.
Yeah.
Right? So as we look at our next model of Duramax, this is a real short run, the 04.5 to 05 LLY. Yes, I know there's 06 LLYs out there. Please don't message me about it. Don't
LBZs.
care about them. They're LBZs.
They're LBZs.
They have LBZs turbochargers.
Stop trying to fight and stop trying to bait us.
We love you. Feel free to message me.
Bait
all right.
Paul.
This is when Duramax dumped the iHigh and they went to the Garrett. Now Garrett's another company with a huge reputation across all automakers.
When you think of turbochargers, the two names that that pop in my head, Borg Warner, Garrett.
Chuck.
Those are like what I would consider the two biggest in turbo manufacturing.
Absolutely. Now, there were some great advantages for this stepping stone of Duramax being the LLY. They went to variable vane technology. They pulled the injectors out of the cylinder heads. They increased some other components that made it great. They also, as a stepping stone, left some opportunities to grow as they went forward.
Well, they also had to implement emissions.
Nicely.
This is when it was federally mandated. They had to implement emissions, which is the main purpose for the VVT style turbo to work directly with the EGR.
That's right. So an EGR redirects exhaust gas back into your intake, into your combustion cycle. Yep. Okay. It works as inert gas. So in design on paper, EGR is actually a really effective way to cool the pistons down, which will lower your NOx emissions. Yep. However, it does cost you exhaust flow, which would usually be driven to your turbocharger. So to get your turbocharger to spool up across a wider range, they've implemented the use of variable vane technology with precise electronic control of the movable vanes that direct exhaust flow across the turbine wheel. Optimum performance is achieved at virtually any engine speed. That's from Mike McLaughlin out of his Driving Line article.
And I guess let's dummy this down a little bit, right?
Please.
Your vanes tighten up, okay? Exhaust gas flows. You're directly driving exhaust gas directly into the turbine in a tighter area. That's going to get the turbo in the motion.
That's right.
Okay?
Yeah. So vanes are these little moving parts inside of the back side of the turbo, inside of the turbine side of the turbo. And just like Chris said, they'll redirect the exhaust flow to apply more or less pressure onto that turbine. That's what's going to speed the turbo. That's what's going to make
turbochargers spool by exhaust energy. That exhaust energy is going to be dictated by RPM.
There you go.
The vanes open and close to help assist.
You got it.
What's ironic about this is the turbocharger, and granted, this is new technology, right? This is their entry into the VVT world. What did they get for a turbocharger with this, Paul?
Okay, so they got what's listed as, when I research it now, it's listed as a Garrett GT 3788 VA. You'll notice that RPO code, or I'm sorry, that SKU is the same for all the way through 2016. Mm-hmm. The turbochargers do change slightly, but Chris, you and I were talking, the 04.5, 05, so our LLYs, your 06, 07 LBZs, and your 07.5 to 2010 LMMs, all of these GT 3788 VAs
are changeable.
Totally interchangeable. Yep. But from the factory at the time when they came out, they were all a little bit different. The LLY featured the largest turbo that's ever been on a Duramax. And a lot of guys think that this is going to mean that you have a lot more peak power potential. But if you remember back, we were about 520 on an LB7. I would say we're realistically like a more conservative race tune, still only going to net you about 520, maybe 550 on an LLY.
Well, I think the thing here, we'll dive into this a little more, but I always tell guys this on the phone, you can't compare turbos for drivability and peak power by compressor, okay? Right. Everything is dictated and driven by exhaust. So what do we have for a turbine wheel on this?
So we went to a 66 millimeter turbine and 15 millimeter tall vanes.
So biggest turbine wheel out of any of the turbochargers in the Duramax lineup, hands down.
Yep.
It also had the loosest exhaust housing.
That's right.
Right?
And the biggest vanes.
So because of that, you're picking up a couple horsepower, but those wheels are huge.
Yes.
Big wheels. So you always get the guys, with the LOIs, I drove my buddy's LMM or I drove my buddy's LBZ and my truck's laggy, I need this, I need that, which there's a reason for that as we go further into this.
Sure. So there's, speaking of the reason being that we run into this turbo mouthpiece is one of the big limitations.
Huge.
On the
Number
LLY.
one on an LLY if you have a stock truck.
It's a no-brainer. It's like $200. You get an S&B kit, or you can go buy a whole LBZ intake system.
That's like, you don't get those anymore. Up. No, that's like a rare thing.
We stopped getting them years ago.
Back in like 14.
Yeah. And the mouthpiece is honestly easier to install anyways. It's less work and it's the same cost. So that the factory turbo mouthpiece creates a low pressure bubble in front of the compressor wheel. This will cost surge. This will cost you horsepower. This will cost you flow.
Brings in a lot of heat.
Also,
it's a restriction.
It contributes towards its lack of heat rejection. They also have small radiators, the smallest radiator out of any Duramax, probably one of the great reasons they have coolant issues. Boost leaks and overspeed are much more prevalent on a VVT as a major issue and a hidden issue than they are on a wastegated charger. So a fixed vane or a wastegated charger, when you get a boost leak, it's usually pretty easy to identify because you're also generally going to give up peak boost. On a VVT, that's not true. So anybody who's talking to you about, I think I have a turbo issue, I have a smoke issue, I have a lag issue, anything with drivability in their truck at all, I'm immediately going to tell them peak boost that they're reading, even if it's with an aftermarket gauge, doesn't mean shit.
Well, dive into that more. Why is that? Right? When we talk about this,
the vanes on the turbo are able to keep twisting or to keep applying more and more exhaust pressure to compensate for a lack of exhaust pressure coming in. So if you're not getting all of the exhaust pressure the truck is expecting because you have a boost leak, your vanes will actually overcorrect and continue to apply more pressure to compensate for that. So you still may see that peak of like, I want to say it's like, God, on a tune, 37 PSI or so out of these. You may still see 37 PSI, even if there's a quarter-size hole in the bottom of your intercooler.
Yep.
Because the vanes are going to keep pushing to try to make up for that.
The turbocharger is actually boosting 40, 42 pounds.
That's right.
Over speeding. And all this has to do with is ECM requirements. The ECM expects to see at X vane, X load, X throttle input, I want to see this boost number. And if the ECM doesn't see the boost number, the truck is so sophisticated, even in an 04.5, to where it will manipulate the vanes to open and close to get to that desired boost number.
That's right.
And that's what ends up falling into, your underboost, overboost codes, vane position codes that you might see. Some of those times it's a boost leak that caused that. We've seen that. We've experienced that.
100%.
So always got to ask the right questions.
We also see quite commonly vane position sensor failures with these trucks, and that a lot of guys will contribute that to sticking vanes due to EGR failure. So if you have a boost leak, you're going to run too much soot through the EGR. You're not getting burnt clean exhaust. You're getting dirty exhaust, and that's going to gum up the EGR, which is then going to translate to gumming up the vanes in the turbo. Then the solenoid is activated to move those vanes based on what the reading is from your vane position sensor. And if the vanes won't stick, that eventually can cause failure in the vanes, failure in the unison ring, failure in the vane position sensor. All these things can be attributed to problems. So if you have an EGR failure, which it being the first generation of EGRs for the Duramax, it's quite common. It can snowball quite quickly. So it's a good thing to keep an eye on. As we move forward, the LBZ and the LMM turbos are very, very similar.
Yeah. So, what I think LBZ and LMMs deserve to be kind of grouped in the same ballpark. Okay.
They do. I only want to call out one difference.
Okay.
It's so stupid. All of their measurements on inducer and exducer are off by a 0.5 millimeter each way.
Yeah.
What adjustments they were making to compensate for a DPF, I have no clue.
The thing that we don't have on here, and this is like really nitty gritty, but there's actually a tighter exhaust housing.
Right.
The aspect ratio on the LMM is tighter than the LPZ.
Hoping to compensate and give it more spool up.
Correct. To help with the air fuel ratios, responsiveness, things like that. And I'll tell you what, man, you get into an LMM and drive one of those trucks tuned compared to the other ones, they are rapidly responsive.
Yeah.
They're impressive. And it's crazy to look at the LLY, biggest charger, biggest turbine, biggest compressor. It made a peak number of like 540, 550, depending on the dyno, right?
Right.
And you get to an LBZ, they go from a 62 millimeter compressor down to a 60. They go from a 66 millimeter turbine down to a 63. They slightly tighten up the turbine. The truck is remarkably more improved as far as responsiveness goes.
Yeah.
Okay. 37 PSI peak, so similar, to what the what the LLY was.
It was. Yep.
But the drivability improvements were just night and day.
It really is.
It really, really was.
And going down that 2 millimeters didn't give up a ton because the size of your compressor wheel will impact your peak power more than spool up and drivability, like you were saying earlier.
It's all about the combination.
Yeah.
It's not just compressor wheel. It's not just turbine. It's not just the exhaust housing. It's the proper pairing of all three.
Yeah.
So,
So like we were saying, these two are very similar. They're both listed roughly as 60 millimeter compressor inducers, 63 millimeter turbine exducers. They're both roughly 37 PSI peak. They're both roughly 520 horsepower. But the differences we see are, like you were saying, aspect ratio. Just for anybody who's new to diesels and they hear us saying aspect ratio, what we're talking about is the distance from the turbine wheel to the exhaust housing. So the gap that's in between those two where the exhaust gases are going to flow between them, that's going to be our aspect ratio. That aspect ratio, the tighter it is, the faster the turbine spins. The wider it is, the more energy it's going to take to turn the wheel.
Absolutely.
So as we start to look, the LBZ and the LMMs, we were just talking about how similar they are. The LML came out, and it's like 60 or 70% redesigned throughout the entire engine. Like the whole engine was overhauled to go into 2011. That was when we saw the introduction of DEF fluids, diesel exhaust fluids, more emission standards, tighter emission standards on what diesel particulates could come out, NOx could come out. So they had to redesign a lot of things, still kept it the same displacement. Now the new RPO. Chris, this GT 3788 V8 also had some upgrades along with it.
Yeah, so I mean they kept the same compressor wheel inducer size. However, they went smaller on the turbine wheel. They went to a 62 millimeter. They went to an 11.2 tall vane, which is slightly smaller than any of the other RPOs, and they went even tighter on the exhaust housing. So that aspect ratio went tighter.
Yep.
And what they were able to get out of this is a turbocharger that's more efficient, down low, a broader mid-range. The torque output, if you compare the LML versus the LMM LBZ LLY truck, the LML will make more torque, and it will make that torque in a broader RPM range.
Right.
And you can drive the turbo harder to make a little bit more of a peak power number.
That's right. Yeah. Yeah, I think we've squeezed 550 out of these. I've seen other guys ride these up to 600. I think you're asking a lot out of your fuel system on a stock setup.
That is, I mean, that turbocharger is way out of its efficiency range at that. But that 540, 550 number, anything more than that, or you're comparing, and arguing about dyno readings.
Yeah, there you go. There you go. Yeah, but this was a wildly new turbo. We were very impressed with it. We see awesome results out of it.
Yeah, it's super reliable.
LMLs also have this a slightly different fuel system, so piezo injection instead of solenoid-based injectors.
They went to a higher injection pressure, which is also going to help aid some of the efficiency of the turbo gain.
There you go.
Injection pressures, like, little side note here, if you were to look at an old 12-valve Cummins that runs low injection pressure, mechanical injection, right, and you compare the turbocharger's ability to create power based off of that fuel system versus a common rail, they're two different scenarios.
100%.
So it's all about utilizing that fuel as energy into the cylinder and utilizing what kind of air volume the turbo can support.
That's right. So our LMLs ran from 2011 to 2016.
Yep.
The LML itself had a slight update around 2015 and a half. Not enough for us to talk about in our turbocharger history because they were the same across the board there. Now, I will just give a heads up before we go further into the L5P that the GT3788 VA on an LML will not swap directly with the older GT3788 VAs. Chris and I, just before recording, I said, hey, man, what if I go to Garrett and I try to buy this model from Garrett? What will they ship me? And honestly, guys, I just didn't check it out, and I haven't done it on my phone while we're recording. I'd love somebody to shoot me a screenshot and show me what Garrett offers if you type this in. But a heads up. So your LLY to LMMs, all interchangeable. You get slightly different results out of each one, but they will bolt on to each other. The LML has a slightly down-angled exhaust.
It's like a 45-degree angle.
Yeah. Yep. So that won't match up to your downpipe. It's a fucking nightmare to try to make it work. And
the oil return where the line bolts up, it's in a different location slightly. So you would have to like extend the line. Just, you know what, guy?
Don't do it.
If anyone's listening to this, you're not gaining anything from doing the swap, right? Just don't do it.
I love that. The L5P. God, we've talked so much about the L5P, Chris.
Well, the L5P is very different in so many ways.
Yes.
And when we talk about the turbocharging system, let's just talk about the relationship that the Duramax motor had with the Garrett turbo, which lasted 11 and a half years, right? From 04 and a half, 12 and a half years, from 04 and a half all the way to 2016. Long run with a lot of improvements along the way.
Yep.
Then the L5P platform comes out.
What's funny is I shouldn't say what's funny. So they redesigned a ton of stuff on the L5P.
Yep.
They went to a new supplier on fuel system, so it's no longer on a Bosch fuel system. It's on a Denso controller. It's on a Denso fuel system.
Yep.
It's on a Denso pump. There was a lot of CP4 failures out there, so I understand the motivation to change there.
Yep.
I was surprised when they went to a Borg-Warner VGT.
Yep.
Two reasons. One, like you said, they've had this over a decade-long relationship with Garrett. Everybody loves LML turbocharger. Never heard a complaint.
Yeah.
It's not like they're 6.4 compound setups.
Right. Or the 2011 to 2014 Garrett chargers on the Power Strokes.
The Power Strokes, the dual
We'll be getting into that.
Right.
That's another episode.
So they didn't have Duramax turbos aren't notorious for failure. So I was surprised when they jumped. I also I think Borg-Warner, I think S300, S400 fixed vane.
Yep.
I didn't even know
that they got into that space.
Borg-Warner had a VGT that I'm sure they developed it specifically for the L5P.
Yep.
It offers a lot of differences, things we've never seen from the factory before.
First glance, you look at the turbocharger, the packaging and the way it's presented to you is very unorthodox from a prior year Duramax.
Yeah.
A couple things that really stand out to me is the electronic VGT controller and where it sits on the compressor housing.
And this is starting to be more and more common.
Yep. That's number one.
Yep.
The second thing that really stuck out to me, and it's not something that you see first glance, but all the other year Duramax turbochargers from 2001 to 2016, it was one complete exhaust unit, meaning the turbocharger had a big exhaust housing that bolted into the center of the engine, and your up pipes bolted into that, from the manifold. Where in the L5P arena, the Borg-Warner turbo actually sits on a pedestal. So your up pipes bolt into a pedestal, which then that pedestal secures the Borg-Warner turbo in place.
All right.
Similar to like what you would see on a Cummins with a T3, T4i style manifold connector. And then it has, the discharge on the exhaust side for the downpipe, which actually makes servicing this turbocharger and getting it on and off the truck a little bit more plausible.
Yeah.
So those were the two things that out of anything on this, I remember a couple of years back, back in 16, getting an L5P engine at our shop over in Marengo and taking a look at it, and just all these little things are like, well, the up pipes are more recessed in, into the valley of the motor, and the turbo kind of sits more in the middle of the engine instead of in the back of the engine. And that's weird. It's sitting on a pedestal. It's two pieces now. Just all these different things now looking back that I was so surprised by.
I think also some of the standouts that I think like anybody walking near the diesel truck world, it's the only time we've seen a billet compressor wheel.
Yeah.
It has now ever since we've gone to VVT, they've always offered an 11-blade compressor wheel. Yep. I know a lot of the modified trucks out there, and even we've done 6-blade wheels for a long time in these. 11-blade wheels reduce surge. Yep. That's like the shortest way I could say the benefits of an 11-blade. It did go from a 60-millimeter compressor to a 61, but what inside really jumps out is the vane pack.
Yeah.
So in the past, we've had a flat unison ring that connects to your solenoid, which is driven by your ECM based on readings from your vane position sensor. So vane position sensor says, hey, the vanes are right here, sends a signal to the ECM. The ECM sends back and says, okay, solenoid, move. That unison ring moves, and then it moves these vanes. It's almost two-dimensional mechanics, where it's not super complex.
It's a very simplistic operation back
there. It is.
Yeah.
I mean, think about this. They put two metal pieces touching each other and no grommets, oiling, cooling. Like the unison ring to the vanes is metal on metal and movement. That's not something we see a lot of inside of an engine outside of like your combustion cylinder, right? But it is very simplistic. Once they went to the Borg-Warner, to this VGT, they went to the smallest vanes I've ever seen. It looks like these vanes belong on a 2.8-liter turbo, not on a 6.6-liter turbo.
There's so many of them.
They're tiny. They're a huge increase in the number of vanes. And the whole cage assembly is no longer a flat plate with vanes that mount on it. It's now a full cage. So it has a ring on the bottom, if you imagine like a circle on the bottom. Then it comes up. Then another ring, then the vanes are inside of there, then another ring, and then the mechanics are there to move it and to control it. And now, instead of sending a signal back to the ECM and back to this, that's what Chris was talking about with that. It has a computer module mounted on top in front of the turbo, so just above the compressor wheel.
Similar to what you see out of like the whole set in the Cummins world.
There you go.
Again, another episode.
Yeah. but yeah, we are starting to see these computers there, and they're reading data and they're responding much quicker, and they're able to store that information in a much more isolated place and access it faster. So you're going to get a faster responding turbo. Also, these much smaller vanes also means they can move quicker.
Yep.
And I really think that's what it's all about, is making sure that you can manage that air-fuel ratio across any range of power. Chris, what do you think we're seeing out of a peak L5P turbo?
I mean, there's been a lot of testing, a lot of data, and I think where the L5P is different is falling back on data collection very early on, where you didn't see that with some of the other Duramax platforms. Guys like Banks Power, ourselves, we did a lot of stuff, and then a lot of the other tuners in the country, once L5P went live with support, all these numbers started coming out. There are guys making 630 wheel horsepower out of one of these stock turbo trucks with over 1,400 foot-pounds of torque. Now, that's
just crazy.
That's pushing. Okay, that's pushing the system. That turbo's not going to live a long life. That is heat. That is hot. No, it's not smart. Where I see this turbocharger making its peak is going to be in that 550 wheel horsepower category. But what's ironic is on 550 horse, the torque the way the truck comes into its torque curve, the peak torque that the engine produces, most 550 horsepower L5P trucks are playing with 1,250 plus rear wheel foot-pounds of torque.
Yeah.
And once you start etching that truck into the 600 horse range, you're playing with mid-1300s. So it's just the turbocharger has an ability to support power, but when we talk about the reliability, I say that 550, 565, somewhere in that ballpark.
Yeah, I'm right there with you. The other big thing that I think was different on the L5P turbo is that GM moved their emission system around and decided to take advantage of the direct heat coming out of a turbo that usually would flow through your exhaust pipe and then down into the DOC. The DOC then superheats that exhaust and burns off the soot inside of your DPF, your diesel particulate filter. GM said, hey, let's move that DOC right onto the back of the turbocharger. So when you look at your turbocharger, you'll see the compressor wheel or the compressor housing, the center section, the exhaust housing, and a DOC all bolted to each other. Kind of a crazy setup. It was kind of shocking or jarring to see for the first time. Mm-hmm. Makes a lot of sense. Seems to work really effectively. We have a very easy time managing regen frequency in an L5P, even when it's cranked all the way up and towing way too much power or towing way too much weight. No problem. So there's some real differences. And I think we've talked about this before, Chris. What we have found drives diesel performance technology at an OEM level are two things: competitor horsepower and torque numbers, emission standards.
Yeah.
Those are really the only two factors we see driving diesel performance getting better. So as they've increased emission standards, what's really awesome to me is how much they've increased performance.
Yeah.
Because like we were talking about that the LB7 being cutting edge at 300 horsepower, L5Ps are rated at 445. We dyno them at 405.
Yep.
That's just how they come.
Yeah.
Right? So, like, they've just thrown that extra 100 horsepower out there, and they've built a reliability along with it. Other things that make that type of power out of the L5P possible may not necessarily be just the turbocharger. It also has the highest flowing heads in the industry. So, like, if you ever dig into any really nerdy stuff, you can go back and listen. We talked with Gail Banks about heads and swirl, like what is swirl. That's all about the L5P heads and how they're different. There's also some great resources out of some of the guys that I had mentioned before that have taken the time to actually build graphics and show you how much more flow is going through the heads. All of that's going to impact your final peak power, right? So the turbocharger, if we threw on a set of LML designed heads onto an L5P, we may give up quite a bit of that peak power. But that's yet to be determined. Nobody would ever try to make their truck less efficient, right? So we probably will never test that. What I did want to talk about here at the end of the show, Chris, was what are some of the things you think could be in store for the future of Duramax turbocharging?
I think one of the biggest things, and I'm hoping, because we are starting to see back in the early 2000s when these trucks, specifically the Duramax, you could take a turbocharger to make 300 horsepower and you could turn the wick up and get to 500, plus wheel horse. And what you see as through all the different RPOs, the base horsepower has increased, but the potential gain in what that turbocharger's capabilities are, there's not as much room to grow. Okay. And as emission standards tighten, right, and get more strict and complex, I think that there's going to be a new era of turbocharging systems. So if these trucks stay, with mechanical turbochargers, right, I think that compound turbos are going to be like one of the newer eras, so to speak. Similar to what we saw in the 6.4 world from 2008 to 2010, I believe, the 6.4 Power Stroke.
Just ones that work.
The ones potentially worked. I could totally see something going like that, and what I think you would get is a even smaller, the secondary turbo, right, which is your small turbo in a compound setup.
Duramaxes, we can call it the Valley Charger.
Yeah, the Valley Charger, and then your atmospheric or primary charger would be much bigger, of course. So
you think instead of like that 60, they've been hovering around 60 millimeter inducer on the compressor wheel for a long time, 62, 58.
I think you'd see like a 55, 56 millimeter compressor inducer on the Valley Rally turbo, and then you would see a turbo probably somewhere in the big 60s, maybe early 70s, low 70s for the atmospheric is what I would assume.
Yeah. Yeah, I think if they go that way, you're right. I think compound turbocharging technology is already used widely on big rigs, agricultural equipment, large industrial machinery.
Stuff out of vehicles that are from like Germany, BMW, stuff like that, like Mercedes. I'm sure like they do stuff like that already.
I wouldn't know anything about that, Chris.
Yeah, you wouldn't. But I think that it's something that it's been tried before in the U.S. diesel pickup market once before, and I think that might be something that ends up making its way back.
We've seen dead technology come back to life and be perfected later. Look at the Cadillac 468.
Jeez.
They all got dragged in. So Cadillac 468 was original displacement on demand is what you would know it as today. But back in whatever it was, 80s, 90s, they rolled out the 468. It was going to be this great technology. It fucking flopped. They dragged them all into the dealership and welded half the cylinder shut and made them all 4 cylinders with just way too much weight. So they were garbage.
Yep.
But now, I don't know that you could buy an 8-cylinder vehicle that doesn't have displacement on demand.
That's like
if you have a gas
thing.
8-cylinder, that's what you're getting.
Yeah.
Parallels. Hey, we see parallel twin chargers on the EcoBoost.
Yeah.
We're starting to see that on more cars. I think some of the European stuff has some parallel twins. You could run really, really small chargers, run one on each bank. Yep. They've gotten better with timing and control and consistency and reliability. That's a possibility. What I would really like to see, personally, is electronically assisted turbochargers, kind of like what we're seeing in F1 right now.
Yeah.
I'm sure most of us don't watch F1, but if you look around electronically assisted, they basically, instead of running that exhaust pressure to spool the turbo, they use that exhaust pressure to generate energy into a battery and convert that energy to run it through a motor. So now I can spool my turbo literally any way I want, and it's not based on things like exhaust pressure. Because now if I have a boost leak, my battery still will compensate. So that will be, my guess being, if they roll that technology out in the next 10 years, the first generation that comes out will fail miserably, and it will be garbage, and it'll never be reliable. And then 5 to 10 years after that, they'll build it so it works.
Yep.
Right? So but I still hope to see it. I think one of the other dead technologies out there that is really, really cool on paper and wildly flopped in the real world was dual scroll from the Fords. They had 11 to 14?
Yeah, the 11 to 14s.
Yeah, 11 to 14 Power Strokes had this dual scroll
compressor,
right? Yep. It's not a dual scroll turbine. I can never remember on those.
It's the
I don't know
dual
those
scroll
real
compressor.
Well.
So you have basically 2 compressor wheels back to back, and then you have 1 turbine wheel. And the idea is the volume of air moved is greater than a single compressor wheel would be. And if I don't know if you've driven a lot of 11 to 14
like one
Power Stroke.
Yeah.
They are insane. Like torquey, good mid-range. They choke up top. But they really, really run well. But the reliability in that turbocharger technology from 11 to 14 just didn't shape up the way that Garrett and Ford hoped for that to end.
Absolutely.
So,
hey, speaking of that, why don't we do history of Power Stroke turbochargers next?
I think
that's the one I know the least about.
Yeah, me too.
So we'll dig in. We'll do some research, and we'll talk to you guys next week. For today, this has been Paul Wilson
and Chris Emke.
Thanks for listening. If you've wasted your money on rims and tires, you'll also like this.